Before we begin tonight's journey, if you find yourself drifting peacefully with this story, we'd be incredibly grateful if you'd use your hype points on this video. It helps the channel grow in ways you might not realize. If you're listening on Spotify, leaving a review means the world to us. And if you'd like, drop a comment telling us what time it is where you are and where in the world you're tuning in from. We absolutely love seeing where everyone's listening. If you enjoy these stories, consider subscribing. It keeps this channel alive and brings you more content like this. Now, settle in. Let your breathing slow. Tonight, we're not chasing mysteries or conspiracies. We're simply looking up at something you've seen every night of your life. Something ancient, something quiet, something that's been watching Earth since before humans had words. The moon. 100 facts, one gentle story. No urgency, no fear. Just the slow, steady presence of Earth's only companion in the darkness of space. Let's begin. The light in the night, it's night on Earth. Somewhere, maybe where you are right now, the sun has set. Shadows stretch across the land, the air cools, birds settle into trees, the world becomes still. And then slowly, the moon rises. It appears above the horizon like it has for billions of years. Silent, glowing, constant. You've seen it 1,000 times. Maybe you've never really thought about it. It's just there, part of the sky, part of the night. But tonight, we're going to look closer. Not with telescopes or satellites, not with equations or charts, just with quiet attention, with wonder, with the kind of curiosity that doesn't need answers immediately. It just wants to understand. The moon is Earth's companion. It hangs in the darkness, reflecting sunlight, pulling at our oceans, stabilizing our world. Humans have watched it for as long as humans have existed. Before cities, before agriculture, before language itself, and tonight we're going to explore it together. 100 facts about the moon, not rushed, not frantic, just gentle. The way moonlight itself moves across a dark room. Take a breath, get comfortable, let the day fall away. The moon is waiting. Chapter 1. What the moon is. Let's start with the simplest question. What is the moon? It's Earth's only natural satellite. A world unto itself, smaller than Earth but still massive, still real. It exists out there in the vacuum of space. Close enough to see clearly, far enough to remain mysterious. The moon is old, over 4 billion years old. It formed in the early days of our solar system, back when Earth itself was young and violent. Most scientists believe the moon was created from a massive impact, a collision between early Earth and another planetary body, roughly the size of Mars. Imagine that moment. 2 worlds colliding in the darkness, debris exploding outward, molten rock spinning into orbit, and slowly over time that debris coalescing, cooling, forming into the sphere we now call the moon. The violence of that creation is hard to comprehend. The energy released would have been unimaginable. The entire surface of Earth would have been molten. The sky would have glowed red and orange with vaporized rock. And from that chaos the moon was born. It's much smaller than Earth. You could fit about 50 moons inside Earth's volume. Its gravity is far weaker, about 1/6 of Earth's. If you weigh 180 pounds on Earth, you'd weigh only 30 pounds on the moon. Jumping would feel like floating. Walking would feel like gliding. There's no breathable atmosphere on the moon, no air to carry sound. If you stood on the lunar surface, you'd hear nothing. Absolute silence. Even if a meteor struck nearby, you wouldn't hear the impact, only feel the vibration through the ground. Think about that silence for a moment. On Earth, we're surrounded by sound. Wind through trees, birds singing, cars passing, voices, music. Even in the quietest room you can hear your own breathing, your heartbeat. But on the moon, there's nothing. Perfect, complete silence. The surface is covered in dust and rock. Grey, powdery, sharp. The result of billions of years of impacts, radiation and temperature extremes. No wind to smooth it, no water to erode it. Just ancient untouched terrain. And yet, despite being unchanging in substance, the moon is always changing in appearance, waxing and waning, growing bright and fading dim, a cycle humans have tracked since the beginning. But through all that change, through every phase, every cycle, every night, the moon remains constant in presence. It's always there, always watching, always returning. Every culture on Earth has stories about the moon. The ancient Greeks saw Selene, goddess of the moon, driving her silver chariot across the sky. The Romans called her Luna. In Chinese mythology, Changi lives on the moon with her jade rabbit. Native American tribes told stories of the moon's relationship with the sun, with Earth, with the seasons. The moon has been a symbol, a deity, a calendar, a clock, a light in the darkness, and now we know it's simply a world, a natural satellite, a companion formed from violence, shaped by time, and forever bound to Earth. Chapter 2. The Moon and Earth. The moon doesn't just hang in the sky, it shapes the Earth. Without the moon, Earth would be different, unstable. Our planet rotates on an axis, tilted at about 23.5 degrees. That tilt gives us seasons, summer and winter, spring and fall, the rhythm of life on Earth. But that tilt isn't permanent. It wobbles, slowly, over thousands of years. And without the moon's gravitational influence, that wobble would be extreme. Earth's tilt could shift wildly, making climates unpredictable, seasons chaotic. The moon stabilizes us. It helps control Earth's rotation, keeping our tilt steady, keeping our seasons predictable, making life, as we know it, possible. Scientists have run simulations of what Earth would be like without the moon. The results are dramatic. Without the moon's stabilizing influence, Earth's axial tilt could vary from 0 degrees to 85 degrees over millions of years. Imagine that. The poles could point almost directly at the sun, then swing back. Climates would shift violently. Ice ages would come and go unpredictably. Life would struggle to adapt. The moon also influences Earth's oceans. Tides rise and fall because of the moon's gravity. Twice a day, in most places, the ocean swells toward the moon, then retreats. This rhythm has shaped coastlines, marine ecosystems, and even human civilizations for millennia. The mechanism is elegant. The moon's gravity pulls on Earth's water, creating a bulge on the side facing the moon. But there's also a bulge on the opposite side, caused by inertia. As Earth rotates, these bulges move around the planet, creating high tides. The areas between experience low, tides. Ancient peoples lived by the tides, fishing, navigation, rituals. The moon dictated when it was safe to travel, when food would be abundant, when storms might come. Coastal communities developed entire calendars based on tidal patterns. They knew which beaches would be exposed at low tide, revealing shellfish and crabs. They knew when tidal currents would be strong, when harbours would be accessible, when it was safe to launch boats. But here's something strange. Something slow and almost imperceptible. The moon is moving away from Earth. Every year the moon drifts about 1.5 inches farther from us. It's pulling away, slowly, gradually, due to tidal forces. The same gravitational interaction that creates tides also transfers rotational energy from Earth to the moon, pushing it gradually outward. Billions of years ago, the moon was much closer. It appeared enormous in the sky, maybe 2 or 3 times larger than it does now. The tides were stronger, days were longer, shorter. Earth rotated faster back then, completing a full rotation in perhaps 18 hours instead of 24. And billions of years from now, the moon will be farther still, smaller in the sky, more distant. But for now, for our lifetimes, it remains close. Earth and moon are gravitationally linked. They orbit a shared centre of mass, locked in an ancient dance. The moon doesn't orbit Earth in a perfect circle. It moves around a point slightly offset from Earth's centre, a point called the barycenter. They move together, always, and because of something called tidal locking, the same side of the moon always faces Earth. always. For all of human history, we've only ever seen one face of the moon. The far side, the dark side, though it's not actually dark, remained hidden until spacecraft finally photographed it. Tidal locking happens when gravitational forces slow down a satellite's rotation until it matches its orbital period. The moon rotates on its axis once every 27 days, exactly the same time it takes to orbit Earth. So the same face is always pointing toward us. For thousands of years, humans wondered, what's on the other side? Now we know. But we'll get to that. Chapter 3: Orbit and Motion. The moon moves. It orbits Earth every 27 days. That's one complete loop around our planet. But because Earth is also moving around the sun, the moon's phases, the cycle from new moon to full moon and back again, takes slightly longer, 29.5 days. This is called the synodic month. It's the period humans have used to create calendars for centuries. The moon's orbit isn't a perfect circle, it's an ellipse, an oval. Sometimes the moon is closer to Earth, sometimes it's farther away. When it's closest, it's called perigee. When it's farthest, apogee. At perigee, the moon is about 226,000 miles from Earth. At apogee, it's about 251,000 miles away. That's a difference of about 25,000 miles. At perigee, the moon appears about 14% larger in the sky than at apogee. You might not notice the difference with your eyes, but it's there. This is why occasionally you'll hear about a supermoon, a full moon that occurs when the moon is at or near perigee. The moon's distance constantly changes, not by much, only about 30,000 miles over the course of a month, but enough to make a difference. Lunar eclipses occur when Earth passes directly between the sun and the moon. Earth's shadow falls across the lunar surface, dimming it, often turning it a deep red or orange. These eclipses can last for hours. They're safe to watch with the naked eye. They've been recorded by civilizations across the world for thousands of years. The red colour during a lunar eclipse happens because Earth's atmosphere bends and filters sunlight. Blue light scatters away, but red light passes through, projecting onto the moon. It's the same reason sunsets are red. Solar eclipses are rarer and more precise. They occur when the moon passes directly between Earth and the sun, blocking the sun's light. For a few minutes, day becomes night. Stars appear. Temperatures drop. It's one of nature's most dramatic events. But here's the remarkable thing. Solar eclipses are only possible because the moon and the sun appear almost exactly the same size in our sky. The sun is 400 times larger than the moon, but it's also 400 times farther away. Pure coincidence, a cosmic alignment that won't last forever. As the moon continues to drift away from Earth, eventually it will be too small to completely cover the sun. Total solar eclipses will become impossible. But that won't happen for hundreds of millions of years. The moon's motion shaped early calendars. Ancient peoples tracked time by watching the moon. Months were lunar cycles, seasons were tied to phases. The moon became a universal clock, visible to everyone, everywhere. The word month itself comes from moon. Many ancient calendars were purely lunar, with each month beginning at the new moon. Some cultures still use lunar calendars today. The Islamic calendar, for example, is based entirely on lunar cycles. Even today, many cultures still follow lunar calendars for religious and cultural events. Easter is determined by the moon. Passover, Ramadan, Diwali, the Chinese New Year. These celebrations don't fall on fixed dates in the solar calendar, they move with the moon. The moon never truly stops moving, it orbits, it drifts, it shifts. But from Earth, it feels steady, predictable, a constant rhythm in the chaos of existence. Chapter 4: The Moon's Surface. If you could stand on the moon, what would you see? Grey, endless grey. The surface is shaped by impacts. For billions of years, asteroids, comets, and meteoroids have slammed into the moon, carving craters large and small. Some craters are only a few feet across, others span hundreds of miles. The largest crater on the moon is the South Pole Aitken Basin, on the far side. It's over 1,500 miles across and 8 miles deep. It's one of the largest impact craters in the entire solar system. The largest impact basins, called Maria, Latin for seas, are dark, flat plains formed when ancient lava flows filled massive craters. Early astronomers thought these dark areas were oceans. They're not. They're solidified lava frozen in time. These lava flows happened billions of years ago, when the moon was geologically active. Volcanic activity filled the low-lying impact basins with molten rock, which cooled and hardened into smooth plains. Today, the moon is geologically dead. No volcanoes, no tectonic activity, just cold, silent rock. The moon has mountains too. Some are taller than Mount Everest. They rise along the edges of impact basins, jagged and sharp, untouched by erosion. The Montes Apenninus, for example, reaches heights of over 18,000 feet. The Leibniz Mountains near the lunar South Pole may be even taller, possibly over 30,000 feet, though measurements are difficult. The dust on the moon is sharp and abrasive. It's not like beach sand. It's more like tiny shards of glass created by eons of micrometeorite impacts. It clings to everything. During the Apollo missions, astronauts found it nearly impossible to brush off. The dust got into everything. It clogged seals, it scratched visors, it stuck to spacesuits, and it had a distinctive smell which astronauts described as similar to gunpowder or burnt charcoal. That smell came from the dust reacting with oxygen in the lunar module after being brought inside. There's no wind on the moon, no water, no weathering. Once something happens on the moon, it stays that way. Footprints left by astronauts in the dust will remain for millions of years, until a new impact or the slow effects of radiation erase them. The surface reflects sunlight. The moon doesn't produce its own light, it simply reflects the sun's rays. That's why it glows, that's why it seems to shine. But the moon isn't a very good reflector. It only reflects about 12% of the sunlight that hits it. The rest is absorbed. That's why the moon looks grey, not white. For comparison, Earth reflects about 30% of sunlight, thanks to clouds, ice, and oceans. Temperatures on the moon swing dramatically. During the lunar day, which lasts about 2 weeks, temperatures can reach 260 degrees Fahrenheit, hot enough to boil water. During the lunar night, which also lasts 2 weeks, temperatures plummet to minus 280 degrees Fahrenheit, colder than anywhere on Earth. Think about that range. Over 500 degrees difference between day and night. No atmosphere to moderate the temperature. No blanket of air to hold heat. The surface is exposed directly to the sun, or to the freezing vacuum of space. There's no atmosphere to moderate the temperature. No blanket of air to hold heat. The surface is exposed directly to the sun, or to the freezing vacuum of space. And yet, despite these extremes, the surface preserves history. Every crater, every rock, every grain of dust is a record, a story, a moment frozen in time. The moon is a museum of the solar system's violent past. Chapter 5. Moon Phases. The moon changes. Every night it looks a little different. Sometimes it's a thin crescent. Sometimes it's full and bright. Sometimes it's not visible at all. These changes are called phases, and they're one of the most beautiful, predictable patterns in nature. The cycle begins with the new moon. This is when the moon passes between Earth and the sun. The side facing Earth is in shadow. We can't see it. The night sky is dark. During a new moon, the moon rises and sets with the sun. It's in the sky during the day, but invisible against the bright sky. Only during a solar eclipse can we see the new moon silhouette. Then slowly the moon begins to wax, to grow. A thin crescent appears in the western sky just after sunset. Night by night it grows wider. First quarter, gibbous. Until finally, about 2 weeks after the new moon, it reaches full. The waxing crescent is delicate, beautiful. In some cultures, seeing the first crescent of the new moon was cause for celebration. It marked the beginning of a new month, a new cycle, a fresh start. The full moon rises as the sun sets. It hangs in the sky all night, bright and round, casting shadows on the ground. It reflects maximum sunlight. It illuminates the world. On a clear night with a full moon, you can read by moonlight. You can see your shadow. The world takes on a silver quality, dreamlike and strange. Colours fade. Everything becomes blue and grey and silver. Then the moon begins to wane. It shrinks. The light fades. Third quarter. Crescent again. Until it disappears and the cycle starts over. The waning crescent appears in the eastern sky just before sunrise. It's the last glimpse before the moon disappears into the new moon phase again. These phases are caused by the angle of sunlight hitting the moon, not by Earth's shadow. That only happens during a lunar eclipse. The phases are simply the moon's way of showing us how it's positioned relative to the sun. Different cultures have named the phases, different meanings, different myths. Some saw the waxing moon as a time of growth and new beginnings, the full moon as a time of power and culmination, the waning moon as a time of release and rest. Full moons were used to track seasons: the harvest moon, the hunter's moon, the cold moon. Each name reflected the time of year, the activities of the people, the rhythm of life. The harvest moon, for example, occurs closest to the autumn equinox. For several nights the moon rises shortly after sunset, providing extra light for farmers bringing in their crops. The hunter's moon follows, providing light for hunting game that has fattened over the summer. Phases influenced farming. Planting and harvesting were often timed to the moon. Moonlight guided night travel. Before electric lights, the full moon was a gift, a natural lantern that allowed work and movement after dark. Phases are predictable. You can calculate them years in advance. There's comfort in that, in knowing that no matter what happens on Earth, the moon will continue its cycle. Repetition creates rhythm. The sky feels alive. Change becomes familiar. And somehow, in a universe of chaos, the moon's phases remind us that patterns exist, that order is possible. Chapter 6. Humans and the Moon. Humans have always watched the moon. Long before writing, before cities, before agriculture, early humans looked up and saw that pale circle in the night. They didn't understand what it was, but they knew it mattered. Myths formed around its glow, gods and goddesses, spirits and omens. The moon became sacred in countless cultures. It was worshipped, feared, celebrated. Early astronomy began with lunar study. Ancient peoples tracked the moon's movements with remarkable precision. Stonehenge, the pyramids, Mayan temples. These structures aligned with lunar cycles. They were calendars, observatories, places to honor the sky. The Babylonians created detailed lunar calendars over 3,000 years ago. They could predict eclipses. They understood the Saros cycle, a period of 18 years after which eclipses repeat in similar patterns. Then came telescopes. Galileo pointed his small instrument at the moon in 1609 and saw mountains, craters, details no one had seen before. The moon wasn't a smooth, glowing disk. It was a world. This discovery was revolutionary. For centuries, people had believed the moon was perfect, unblemished, perhaps even divine. But Galileo's telescope revealed the truth. The moon was rough, cratered, imperfect, just like Earth. Over centuries, astronomers mapped the moon, named its features, studied its motion, and as technology advanced, humans began to dream of reaching it. The Sea of Tranquility, the Ocean of Storms, the Sea of Serenity. These names, given by early astronomers who thought they were looking at water, remain today, reminders of how little we once knew. Spaceflight made the moon reachable. In 1969, humans landed on the moon for the first time. Apollo 11, Neil Armstrong, Buzz Aldrin, Michael Collins. Footprints were left in the dust. Experiments were set up. Rocks were collected and brought back to Earth. For the first time in history, humans stood on another world. Armstrong's first words, "That's one small step for man, one giant leap for mankind." Or perhaps for a man. The audio is unclear, but the meaning is the same. Humanity had left Earth. Those footprints remain today, undisturbed, waiting. More missions followed. More landings, more exploration. Knowledge increased dramatically. We learned about the moon's composition, its history, its formation. We learned that it's not just a barren rock. It's a key to understanding Earth's past. 12 people have walked on the moon, all between 1969 and 1972. All American, all men. The last person to walk on the moon was Eugene Cernan, commander of Apollo 17. But then the mission stopped. Humans left. The moon became a destination we visited briefly and then abandoned. No permanent settlements exist. Human presence was brief. A few years of exploration, then silence. The moon stayed unchanged. And yet, interest is returning. New missions are being planned. New technologies developed. Humans may walk on the moon again, maybe soon. But even if we don't return, even if we never build cities there, the moon will remain. Watching, waiting. It doesn't need us. But maybe, in some quiet way, we need it. Chapter 7. The Far Side. For all of human history, we could only see one side of the moon. The same face. Always. Night after night. Generation after generation. The far side remained hidden. People wondered what was there. Some imagined civilizations. Others thought it might be hollow, or different somehow. Science fiction writers spun tales of secret bases and alien outposts. But the truth is simpler and stranger. The far side isn't dark. That's a misconception. It receives sunlight just like the near side. It has its own lunar day and night. It's called the far side simply because we can't see it from Earth. When spacecraft finally photographed the far side in 1959, a Soviet probe called Luna 3, scientists were surprised. It looks different. Heavier cratering, fewer Maria, those dark lava plains. The crust is thicker, the terrain more rugged. No one's entirely sure why. Theories exist. Maybe the far side faced away from Earth during the period of heavy bombardment. Maybe the crust cooled differently, maybe it's just chance. One theory suggests that when, the moon was young and molten, Earth's gravity pulled heavier elements toward the near side, leaving the far side with a thicker, lighter crust that lava couldn't easily break through. But one thing makes the far side unique: radio silence. Because the moon blocks Earth signals, the far side is shielded from all our radio noise. No broadcasts, no interference. Just the faint whispers of the cosmos. This makes it ideal for future telescopes. Radio telescopes placed on the far side could listen to the universe without Earth's chatter drowning out the signals. They could detect faint transmissions from the early universe, from distant galaxies, from places we can't currently observe. Imagine building an observatory there, on the far side of the moon, in permanent radio silence, listening to signals from the edge of the universe. Signals that left their source billions of years ago, travelling through space, finally reaching a receiver on the far side of Earth's companion. The far side remains mysterious. Fewer missions have explored it. Fewer images exist. It's the moon's hidden face, still revealing its secrets. And maybe that's fitting. Maybe it's good that some places remain a little unknown. Chapter 8. Water and Resources. For a long time, scientists believed the moon was completely dry. No water, no ice, nothing. But they were wrong. Water ice exists at the poles. It hides in permanently shadowed craters, places where sunlight never reaches. Temperatures in these craters remain extremely low, cold enough to trap water ice for billions of years. This ice never sees sunlight. It's ancient, pristine. Some of it may have come from comets that struck the moon eons ago. The discovery changed everything. Water means the moon could support future missions. Astronauts could extract water, convert it into drinking water, or split it into hydrogen and oxygen for fuel. The first hints of water on the moon came in the 1990s, but it wasn't until more recent missions that scientists confirmed substantial ice deposits, particularly in craters at the South Pole. Oxygen is also locked in lunar soil, not as breathable air but chemically bound in minerals. With the right technology, it could be extracted. The moon holds resources, not oil or gold, but materials that could enable exploration. Helium-3, a rare isotope, exists in lunar soil. It could be used for future fusion reactors if that technology ever becomes viable. Helium-3 is extremely rare on Earth but relatively abundant on the Moon, deposited by the solar wind over billions of years. Some scientists believe it could power clean fusion reactions, though that technology doesn't exist yet. The Moon could support deep space travel. A base on the Moon could serve as a launching point for missions to Mars, asteroids, or beyond. Lower gravity makes launching spacecraft easier. No atmosphere means no air resistance. Interest in returning grows. Space agencies around the world are planning missions. China, India, the United States, private companies too. China has sent multiple rovers to the Moon, including one to the far side. India has sent orbiters. The United States is planning the Artemis program, aiming to return humans to the Moon and establish a permanent presence. But for now, the Moon remains quiet, untouched, except for those few footprints from decades ago. Science advances quietly. New discoveries are made, new theories proposed, and the Moon waits. Chapter 9. The Moon's Future. What does the future hold for the Moon? It will continue drifting away, slowly, inch by inch, year by year. In about 600 million years, it will be far enough that total solar eclipses will no longer occur. The Moon will appear too small in the sky to cover the Sun completely. Eclipses will one day cease, but that's far in the future. For now, for countless generations to come, the Moon will look much as it does tonight. Its surface will remain mostly unchanged. New impacts will occur, small ones mostly. Meteorites will continue to strike. Dust will shift slightly, but the big craters, the mountains, the Maria, they'll stay. Humans may return, perhaps soon, perhaps in decades. We may build bases, live there, work there. Use the Moon as a stepping stone to the rest of the solar system. Imagine a future where the Moon has permanent settlements, domed habitats where people live and work, telescopes scanning the universe, mining operations extracting resources, launch facilities sending ships deeper into space. Or perhaps we won't. Perhaps the Moon will remain as it is, distant, untouched, observed but not inhabited. Either way, the Moon will keep watching Earth. It always has. Eventually, billions of years from now, the Moon's drift will slow. It will reach a stable distance where tidal forces balance out. Earth's rotation will slow enough that one side always faces the Moon, just as one side of the Moon always faces Earth now. But that won't happen for billions of years. Long after humanity is gone, whatever happens to us, the Moon will be there, still above us. The Moon hangs quietly in the sky tonight, unchanged while Earth moves below. Continents shift, oceans rise and fall, civilizations rise and crumble, but the Moon remains, a steady presence through time. 4 billion years ago it formed in violence, and for 4 billion years it's orbited Earth, silent, constant, watching. Humans have looked up at it for as long as humans have existed. We've worshipped it, studied it, walked on it, and still, it remains mysterious. Still, it holds secrets. But maybe that's okay. Maybe the Moon doesn't need to be fully understood. Maybe its value is simply in being there, in rising every night, in pulling the tides, in reflecting the sun's light when the world goes dark. 100 facts, one story, one moon. It's been there all along. It will be there tomorrow night, and the night after that. Wherever you are, whatever time it is, if you look up, you might see it. A pale circle in the darkness, Earth's companion, quiet, ancient, beautiful. Think about all those footprints still there on the surface, preserved in dust that hasn't moved in over 50 years. Someday, someone might visit those sites again, stand where Armstrong stood, see those boot prints, still perfect, still clear, or maybe not. Maybe they'll remain undisturbed for centuries, millennia, until some impact finally erases them, or until the slow erosion of radiation and micrometeorites wears them away. Either way, The moon continues. It doesn't mark time the way we do. It doesn't worry about the future or dwell on the past. It simply exists, moving through space, reflecting light, pulling at Earth's waters. Rest now. Let your mind drift like moonlight across water. Let your breathing slow like the lunar cycles, predictable, peaceful, eternal. The moon is watching. It always has been. It always will be. Good night. If you're enjoying this journey into the deep, please consider using your hype points on this video. It helps the channel more than you could possibly know. If you're listening on Spotify, leaving a review makes an incredible difference for us. We'd also love to hear from you in the comments. Tell us what time it is where you are and where in the world you're tuning in from, but only if you want to share. We absolutely love seeing where everyone is listening, and if you're finding value in this content, subscribing means the world to us. Now, let's descend together into the endless blue. Imagine standing at the edge of the world. Before you stretches an expanse so vast that it defies comprehension. The surface moves with rhythms older than mountains, older than continents, older than the very air we breathe. This is the ocean, Earth's first environment, Earth's greatest mystery. And tonight, we're going to explore it together, one gentle revelation at a time. Most people think, they know the sea. They've stood on beaches, felt waves against their feet, watched the horizon blur into infinity. But the ocean you see is merely a skin stretched across something far deeper, far stranger, far more essential than we can imagine from the shore. The water that touches the sand is just the beginning. Below lies a world of absolute darkness, crushing pressure, and life forms that seem borrowed from dreams. Tonight, you don't need to do anything. Just listen. Just let the facts wash over you like gentle currents. We're going to descend slowly through 100 truths about the ocean, each one a small window into the largest feature of our planet. There's no rush. The ocean has been here for billions of years. It will be here long after we're gone, so breathe, settle in, and let's begin our journey into the deep. Chapter 1. The World of Water. The ocean covers just over 70% of Earth's surface. Think about that for a moment. If you could see our planet from space, you wouldn't call it Earth. You'd call it ocean. The blue dominates everything. The land masses, the continents we think are so important, they're just scattered fragments floating in an endless sea. Almost all of the water on Earth is contained in the ocean. Rivers, lakes, glaciers, clouds. All of it combined makes up only a tiny fraction of the water that exists in the sea. The ocean holds nearly all of it, has held it for longer than life has existed on land, and will continue holding it long after our civilizations have faded into memory. The ocean controls our climate, not influences it, controls it. Every breath of wind, every rainstorm, every heat wave and cold snap, the ocean has shaped it. Water holds heat differently than land. It absorbs the sun's energy during the day and releases it slowly through the night. It moves warmth from the equator toward the poles. It drives the great circulation patterns that determine whether a region floods or withers in, drought. Temperature regulation across the entire planet depends on the ocean. Without it, Earth would experience temperature swings so extreme that complex life would be impossible. Coastal regions would boil during the day and freeze at night. The interior of continents would become uninhabitable deserts. But the ocean stabilizes everything. It keeps our world within the narrow band of conditions that allows forests to grow, crops to flourish, and animals to thrive. Weather patterns are born at sea, hurricanes form over warm ocean water, monsoons are driven by temperature differences between land and sea. The El Niño cycle, which affects climate across the entire Pacific and beyond, is purely an ocean phenomenon. When people talk about weather, they're really talking about what the ocean is doing. Here's something most people don't realise. The ocean produces somewhere between 50 and 80% of Earth's oxygen. Not the rainforests, not the great forests of the north. The ocean. Tiny organisms called phytoplankton, floating near the surface in numbers beyond counting, perform photosynthesis just like plants on land. They take in carbon dioxide and release oxygen. Every other breath you take comes from the sea. The ocean also absorbs enormous amounts of carbon dioxide from the atmosphere. About 30% of all the carbon dioxide we release ends up dissolved in seawater. Without this natural absorption, climate change would be progressing far more rapidly than it is. The ocean acts as a buffer, slowing down changes that would otherwise overwhelm terrestrial ecosystems. The ocean is older than life on land. When the first organisms crawled out of the water and began adapting to terrestrial existence, the ocean had already been teeming with life for hundreds of millions of years. Every lineage of land animals can trace its ancestry back to the sea. We came from there. Our cells still carry chemical traces of the salt water that once surrounded our earliest ancestors. The ocean is constantly in motion. Waves travel across its surface. Currents flow through its depths. Tides rise and fall with the pull of the moon. Nothing about the ocean is truly still. Even in the deepest trenches where pressure is crushing and darkness is absolute, water still moves. Slowly, invisibly, but always in motion. Yet despite all this movement, the ocean is deeply stable. Its temperature changes slowly. Its chemistry remains relatively constant. Its basic structure, the layers of different densities and temperatures, persists across centuries. The ocean absorbs shocks. It dampens extremes. It maintains equilibrium even as the world around it changes. Chapter 2. Layers of the Sea. Sunlight penetrates only the uppermost layer of the ocean. Below about 200 meters, depending on water clarity, there is no light at all. The bright blue world we imagine when we think of the ocean exists only in a thin film at the surface. Everything. Below is something else entirely. Most ocean life lives near the surface, in that narrow band where sunlight can reach. Here, photosynthesis is possible. Here, the base of the food chain begins. Phytoplankton bloom in the light. Small fish feed on them. Larger fish feed on the smaller ones. The entire structure of marine life depends on this illuminated zone. Below the sunlit zone lies the twilight zone, a region where some light still penetrates, but not enough for photosynthesis. It's dim, perpetually dusk, a transition between the world of light and the world of absolute darkness. Strange creatures live here, adapted to low-light conditions, many of them capable of producing their own bioluminescence. Deeper still is the midnight zone, where no natural light reaches at all. Here, in the vast majority of ocean water by volume, darkness is total and permanent. The only light comes from living things, from bioluminescent organisms that create their own glow through chemical reactions. For them, light is not something that comes from above. Light is something they make themselves. Pressure increases dramatically with depth. At the surface, water pressure is the same as air pressure. But with every 10 meters of depth, pressure increases by roughly 1 atmosphere. At the bottom of the deepest trenches, pressure is over 1,000 times greater than at the surface. It would instantly crush any human body. It would collapse metal spheres like tin cans. Yet life persists even there. The deepest parts of the ocean remain almost entirely unexplored. We know more about the surface of Mars than we do about the bottom of our own ocean. Trenches that plunge more than 10,000 meters down have been visited only a handful of times. Vast areas of the deep sea floor have never been mapped in detail. We don't know what lives there. We don't know what geological processes are happening. We're essentially ignorant of most of our own planet. The ocean floor is not flat. It has mountains taller than any on land. It has canyons deeper than the Grand Canyon. It has vast plains stretching for thousands of kilometers. It has features we're only beginning to understand. Underwater mountain ranges called mid-ocean ridges run through every ocean on Earth, creating new seafloor through volcanic activity. The deepest ocean trenches are deeper than Mount Everest is tall. If you placed Mount Everest at the bottom of the Mariana Trench, its peak would still be more than 2,000 meters underwater. The scale is difficult to comprehend. We think of mountains as the ultimate vertical feature of our planet, but the ocean has carved spaces even more profound. Temperature drops rapidly as you descend. Surface water can be warm, even tropical. But below a few hundred meters, temperature falls close to freezing and stays there. The deep ocean is cold. Not just cool, but near the freezing point of seawater, which is slightly below 0 Celsius because of the salt. This cold, dense water sits at the bottom of the ocean, barely moving, barely changing. Darkness dominates most of the ocean. The bright, sunlit surface is an anomaly, a thin exception to the general rule of the sea. If you could experience the ocean as it truly is, by volume, you would find yourself in cold, dark water, under immense pressure, surrounded by stillness. That is the ocean's natural state. Everything else is a surface phenomenon. Chapter 3. The living floor. The ocean floor is constantly changing. New crust is created at mid-ocean ridges. Old crust is destroyed at subduction zones. The seafloor is not permanent. It is not ancient. In fact, no seafloor is older than about 200 million years, which is young in geological terms. The oldest rocks on continents are more than 4 billion years old, but the ocean floor is constantly recycled. Mid-ocean ridges are underwater volcanic mountain ranges where tectonic plates pull apart. Magma rises from deep within the earth, cools into new rock, and becomes part of the seafloor. This process happens slowly, maybe a few centimeters per year, but it never stops. New ocean floor is always forming. Underwater volcanoes exist throughout the ocean. Some rise above the surface to become islands. Others remain submerged, hidden mountains that never break through the waves. Volcanic activity shapes the seafloor, creating new terrain, altering chemistry, releasing minerals into the water. Earthquakes often begin underwater, where tectonic plates grind against each other beneath the ocean. These underwater earthquakes can be massive, releasing energy equivalent to thousands of nuclear weapons. When they displace large volumes of water, they create tsunamis, waves that can travel across entire ocean basins at speeds of hundreds of kilometers per hour. Hydrothermal vents support ecosystems unlike anything on the surface. These vents, essentially underwater hot springs, spew mineral-rich water heated by volcanic activity. The water can reach temperatures of hundreds of degrees far above boiling point, but the pressure keeps it liquid. Around these vents, life thrives in total darkness, feeding not on sunlight, but on chemicals. The ecosystems around hydrothermal vents are completely independent of photosynthesis. Bacteria convert chemicals like hydrogen sulfide into energy. Other organisms feed on the bacteria. Tube worms, some of them several meters long, host these bacteria inside their bodies. Strange shrimp cluster around the vents. Fish adapted to extreme conditions patrol the edges. It's life based on an entirely different energy source than almost everything else on Earth. The seafloor spreads slowly but constantly. As new crust forms at mid-ocean ridges, older crust is pushed away in both directions. The Atlantic Ocean, for example, is gradually widening. The distance between Europe and North America increases by a few centimeters every year. It's imperceptible on human timescales, but profound over millions of years. Tectonic plates drift over millions of years, carrying continents with them. The ocean facilitates this movement. Seafloor spreading and subduction are parts of the same system, the great engine of plate tectonics that reshapes the surface of our planet. Continents collide and break apart, mountains rise and erode away, and through it all, the ocean remains. All the continents once fit together into a single landmass called Pangaea. That supercontinent broke apart and the fragments drifted to their current positions. The ocean filled the gaps between them. Looking at a map, you can still see how the coastlines of Africa and South America fit together like puzzle pieces. The Atlantic Ocean is the space that opened up between them. The ocean hides Earth's history. Sediment accumulates on the seafloor layer upon layer, recording climate changes, volcanic eruptions, meteor impacts. Scientists extract cores of this sediment, reading it like a book, reconstructing what Earth was like millions of years ago. The ocean floor is an archive of the planet's past. Chapter 4: Life in the Blue. The ocean contains millions of species. Some estimates suggest there could be 10 million or more distinct forms of life in the sea. Most are small, many are microscopic, but they represent an incredible diversity of forms, strategies, and adaptations. Many species remain undiscovered. Despite centuries of marine biology, we're still finding new organisms regularly. Every deep-sea expedition brings back creatures that have never been seen before. Every survey of coral reefs reveals species that weren't in any catalogue. The ocean's biodiversity is vast, and we've only begun to document it. Life exists at all depths in the ocean, from the brightest surface waters to the darkest trenches, from warm tropical shallows to freezing polar seas. Life has found a way to persist. There is no part of the ocean that is truly barren. Some organisms produce their own light through bioluminescence. This ability is incredibly common in the ocean, especially in deep water where sunlight never reaches. Fish, squid, jellyfish, even bacteria can generate light through chemical reactions. Some use it to attract prey, others use it to communicate, some use it to confuse predators. In the midnight zone, bioluminescence is more common than not. Most organisms there have some ability to produce light or detect it. The darkness is not truly dark. It's punctuated by flashes, glows, sparkles. An alien landscape of biological light shows happening in complete isolation. Most marine life is small. Plankton, tiny drifting organisms, make up the vast majority of living things in the ocean by number. They're invisible to the naked eye, but they form vast clouds, blooms that can be seen from space when conditions are right. They are the foundation of everything else. Plankton forms the base of the marine food web. Everything depends on it. Small fish eat plankton. Larger fish eat the small fish. Marine mammals, seabirds, and humans eat the large fish. Remove the plankton, and the entire structure collapses. They are essential, invisible, and often ignored. Large animals depend entirely on tiny ones. The blue whale, largest animal ever to exist on Earth, feeds on krill, small shrimp-like creatures only a few centimeters long. Whale sharks, another giant, feeds on plankton. Size is no protection without the base of the food web intact. Some species live for centuries. Certain sponges and corals can survive for hundreds of years. Some deep sea fish grow extremely slowly and may live for over a century. There are organisms in the ocean today that were alive when the first European explorers crossed the Atlantic. Other organisms live for only days or weeks. Many small plankton have lifespans measured in days. They bloom, reproduce, and die in rapid cycles. Their entire existence is brief but incredibly productive. They turn over generations quickly, adapting rapidly to changing conditions. Migration spans entire oceans for some species. Sea turtles cross thousands of kilometers between feeding grounds and nesting beaches. Some fish migrate from cold waters to warm and back again. Whales travel from polar feeding areas to tropical breeding grounds. The ocean is not divided by borders. It is continuous, and animals treat it that way. Communication happens through sound underwater. Light doesn't travel far in water, but sound does. Whales produce songs that can travel hundreds of kilometers. Dolphins use echolocation to navigate and hunt. Fish make sounds by vibrating their swim bladders. The ocean is not silent. It's filled with clicks, whistles, moans, and songs. Many species demonstrate high intelligence. Octopuses solve puzzles, use tools, and show problem-solving abilities that rival some mammals. Dolphins work together in complex social groups. Whales have cultures, with different populations developing different behaviors. Intelligence in the ocean is widespread and diverse. Cooperation is common among marine species. Fish form schools for protection. Cleaner fish remove parasites from larger fish in mutually beneficial relationships. Coral and algae form partnerships that build entire reef ecosystems. The ocean is not just competition. It's also cooperation, symbiosis, and mutual support. Balance keeps marine ecosystems stable. Predator and prey populations oscillate around equilibrium. Nutrients cycle through food webs. Energy flows from the sun through plankton, through fish, and back to the seafloor. Remove one part, and the whole system shifts. The ocean maintains itself through countless interconnected relationships. Chapter 5: The Ocean in Motion. The ocean is never truly still. Even what appears to be calm water is in constant subtle motion. Currents flow beneath the surface. Internal waves propagate through different density, layers. The entire ocean breathes, expands and contracts with temperature changes, rises and falls with tides. Currents move heat globally, redistributing warmth from the equator toward the poles. Without ocean currents, tropical regions would be unbearably hot, and polar regions even colder than they are now. The Gulf Stream, for example, carries warm water from the Caribbean toward Europe, making the climate there much milder than it would otherwise be. Surface currents are driven primarily by wind. The great circular patterns of current in each ocean basin, called gyres, are created by consistent wind patterns, pushing water in the same direction over thousands of kilometers. These currents can flow faster than a person can walk, carrying water, heat, and marine life with them. Deep currents are driven by differences in temperature and salinity. Cold, salty water is denser than warm, fresh water. This dense water sinks and flows along the ocean floor, creating deep currents that move independently of surface winds. These deep currents are slower than surface currents, but carry enormous volumes of water. Thermohaline circulation connects all the oceans through a global conveyor belt of moving water. Water sinks in the North Atlantic, flows south along the ocean floor, rises in the Indian and Pacific Oceans, and returns to the North Atlantic as a surface current. This circulation takes centuries to complete one full cycle. Water can take hundreds of years to complete the full thermohaline circulation. Water that sinks in the North Atlantic today may not return to the surface until 300 or 400 years from now. The ocean operates on timescales that dwarf human lifespans. What seems permanent to us is just a momentary configuration in the ocean's long cycles. Tides are controlled by the gravitational pull of the moon, and to a lesser extent the sun. As the moon orbits Earth, its gravity pulls on the ocean, creating a bulge of water that follows the moon around the planet. This creates high tides in regions directly under the moon and on the opposite side of Earth. Low tides occur in the regions between. Some locations experience tides that rise and fall dozens of feet. The Bay of Fundy in Canada has the highest tides in the world, with differences between high and low tide reaching more than 15 meters. Other locations have barely noticeable tides. The geography of coastlines and ocean basins shapes how tides manifest in any given place. Waves transfer energy across the ocean, not water. This is difficult to understand because waves look like water, moving horizontally across the surface. But actually the water itself mostly moves in circular patterns. It's the waveform, the energy, that travels. Only at the very crest of a wave does water actually move forward significantly. Storms shape coastlines through the power of waves. Large storms generate huge waves that crash against shores with tremendous force. Over time, this erosion cuts away at rock, reshapes beaches, and creates the coastal landscapes we see today. Storms are destructive in the short term, but creative over geological time. Swells can travel thousands of kilometers from their origin. A storm in the South Pacific can generate waves that travel all the way to the coast of California. By the time they arrive, the storm is long over, but the energy it released continues traveling through the ocean. Surfers learn to read swell patterns, tracking distant storms to predict wave conditions. Even calm seas are in constant motion beneath the surface. Internal waves, invisible from above, propagate through layers of different density water. Eddies form and dissipate. Upwelling brings nutrients from the depths to the surface. The ocean is never static, never frozen in place. It is always becoming something slightly different than it was. The ocean breathes with the planet. It expands when warm, contracts when cold. It releases water vapor that forms clouds and rain. It absorbs gases from the atmosphere. It participates in Earth's great cycles, the movement of water, carbon, oxygen, and energy that makes life possible. Motion creates life in the ocean. Without currents, nutrients would accumulate on the seafloor and never return to the surface where life is most abundant. Without upwelling, productivity would collapse. Without mixing, the ocean would stratify into lifeless layers. Movement is essential, yet there is stillness within all this movement. In the deepest parts of the ocean, water moves so slowly that a current of a few millimeters per second is considered significant. Time passes differently there. Change happens but gradually, almost imperceptibly. It's a different kind of existence, one measured in centuries rather than seconds. Chapter 6. The Sensory Ocean. Sound travels much farther underwater than in air. In the deep ocean, under the right conditions, sound can travel thousands of kilometers, with little loss of energy. Low-frequency sounds like the songs of blue whales can span entire ocean basins. Before the noise of human shipping filled the seas, whales likely communicated across incomprehensible distances. Whales produce some of the loudest biological sounds on Earth. A blue whale's call can reach intensity levels greater than a jet engine. Yet in the ocean, this sound is not violence, but communication. The water carries it gently, spreading it out over vast distances. Other whales can hear these songs and respond, maintaining social bonds even when separated by hundreds of kilometers. Darkness dominates most of the ocean. Below 200 meters, sunlight fades to nothing. The deep ocean exists in permanent night. For most marine life, the sun is irrelevant. They evolved without any reference to daylight. Their entire existence unfolds in darkness. Sunlight penetrates briefly in the upper layers. In clear tropical water, sunlight can reach perhaps 200 meters down before disappearing entirely. In murky coastal water, light may penetrate only a few dozen meters. Water is far less transparent than air. What seems clear to us is actually filtering and absorbing light constantly. Colours disappear with depth in a specific sequence. Red light is absorbed first within the first few meters of water. This is why many deep-sea creatures are red. In an environment with no red light, being red makes you effectively invisible. You appear black to any observer. Orange and yellow disappear next, then green. By the time you reach 30 or 40 meters deep, almost all colour is gone. The world becomes increasingly blue, then dark blue, then black. The vibrant colours we associate with tropical reefs exist only in the shallowest water, where sunlight still penetrates fully. Blue light travels deepest because water absorbs it least. This is why the ocean appears blue from above. The blue wavelengths of sunlight penetrate deeper than others and scatter back toward the surface, creating the colour we see. But even blue light eventually fails. Past a certain depth, all light is gone. Pressure at depth alters perception and sensation in ways difficult for surface-dwelling creatures to understand. Materials behave differently under extreme pressure. Chemical reactions proceed at different rates. Physical forces that seem universal on land become muted or irrelevant. The deep ocean is not just a darker, colder version of the surface. It's fundamentally different. Silence is rare in the ocean. Between waves breaking on the surface, thermal expansion causing ice to crack, tectonic plates grinding against each other, marine life communicating and feeding, the ocean produces constant sound. Hydrophones placed underwater reveal a cacophony we cannot hear from above. The ocean hums constantly with a background of natural sound. Snapping shrimp create crackling noises. Fish grunt and moan. Ice groans as it moves. Waves create a steady rumble. Earthquakes resonate through ocean basins. The sea is alive with sound, a soundscape as complex and layered as any terrestrial environment. Chapter 7. Humans and the Ocean. Humans have always been drawn to coastlines. Archaeological evidence suggests our ancestors spent time near water, gathering shellfish, fishing in shallow areas. Many anthropologists believe human evolution was influenced by coastal environments. We learned to exploit marine resources early in our history. Early human travel often followed coastlines. Migration out of Africa likely followed the shores of the Red Sea and Indian Ocean. Coastal routes provided food, water, and navigation aids. The ocean wasn't a barrier but a highway, a relatively easy path between distant lands. The ocean enabled global trade networks that connected civilizations. Phoenicians, Polynesians, Vikings, Chinese, Arabs, all developed seafaring cultures that used the ocean to transport goods, ideas, and people across vast distances. The modern world was built on maritime trade routes established centuries or millennia ago. Navigation by sea shaped the development of civilizations. Societies with strong seafaring traditions often became regional powers. Access to the ocean meant access to resources, trade, and military advantage. Coastal cities became centers of wealth and culture. The ocean was opportunity. Fishing sustained communities around the world for thousands of years. Before agriculture, before herding, humans were fishing. It was one of our earliest forms of food production, and it remains essential for billions of people today. The ocean has always fed us. Myths and stories formed around the sea in every culture. Sea gods, monsters, lost lands, cursed ships. The ocean inspired awe and fear in equal measure. It was a place of mystery, where the normal rules seemed suspended. Storytellers filled it with wonders and terrors. Fear and respect for the ocean coexisted in maritime cultures. Sailors knew the sea could turn violent without warning. Storms could appear suddenly. Ships could disappear. The ocean demanded respect. Those who treated it lightly often paid with their lives. Serious ocean exploration came surprisingly late in human history. While people sailed across the surface for millennia, understanding what lay beneath was nearly impossible until recent times. The deep ocean was unknown, unreachable, speculative. We mapped the surface but remained ignorant of the depths. Much about the ocean remains unknown even today. We've explored less than 5% of the ocean floor in any detail. We don't know how many species live there. We don't fully understand deep ocean currents or how climate change will affect them. The ocean keeps its secrets. Technology has revealed only fragments of the ocean's nature. Sonar, submarines, remotely operated vehicles, satellites, all have contributed to our understanding. But the ocean is vast and our tools are limited. Every new technology reveals more mysteries than it solves. Humans mapped outer space faster than the ocean floor. We have better maps of Mars, Venus, and the Moon than we do of most of the deep ocean. This seems absurd, but it reflects the fundamental difficulty of exploring an environment that is dark, cold, under extreme pressure, and filled with water that corrodes and obscures. Submersibles can reach only limited depths, and only for brief periods. The deepest parts of the ocean have been visited fewer times than people have walked on the moon. It's expensive, dangerous, and technically challenging. Each expedition is a major undertaking requiring years of preparation. The ocean resists human control. We cannot manage it the way we manage land. We cannot build permanent structures in the deep sea. We cannot regulate its temperature or alter its currents. It operates by its own rules, indifferent to human desires. The ocean outlasts civilizations. Rome rose and fell. Empires came and went. Cities were built and abandoned. And through it all, the ocean remained essentially unchanged. It will be here long after our current civilization fades. It is permanent in a way human achievements are not. The ocean remains essential to human survival. It produces oxygen. It regulates climate. It provides food. It enables trade. Modern civilization depends on the ocean just as much as ancient coastal villages did. We often forget this, living inland, surrounded by concrete and steel. But the dependency remains. Chapter 8. The Changing Sea. The ocean absorbs much of the excess heat generated by climate change. Over 90% of the heat trapped by greenhouse gases ends up in the ocean. This has slowed atmospheric warming significantly, but it's altering the ocean itself. Water temperature is rising, slowly but measurably. Warming affects ocean currents in ways that are still not fully understood. As temperature gradients change, current patterns may shift. The thermohaline circulation could slow or change routes. These changes could have profound effects on regional climates around the world. Coral reefs are particularly sensitive to temperature changes. Corals have a narrow temperature tolerance. When water becomes too warm, they expel the symbiotic algae that give them colour and nutrients. This bleaching weakens the coral and can lead to death if conditions don't improve quickly. Large-scale bleaching events are becoming more frequent. Ocean acidification is altering marine chemistry. As the ocean absorbs carbon dioxide from the atmosphere, it becomes slightly more acidic. This makes it harder for organisms to build shells and skeletons from calcium carbonate. Corals, shellfish, and plankton are all affected. The impacts ripple through food webs. Sea levels are rising slowly but steadily. Thermal expansion as water warms accounts for much of this rise. Melting ice sheets and glaciers contribute additional water. The rate of rise is accelerating. Coastal communities around the world will face increasing challenges in the coming decades. Ice melt impacts ocean salinity, especially in polar regions. Fresh water from melting glaciers dilutes seawater, changing its density and affecting current formation. In the North Atlantic, where dense salty water sinks to drive deep ocean circulation, changes in salinity could disrupt global ocean patterns. Change in the ocean happens gradually. Unlike atmospheric weather, which can shift in hours or days, ocean changes unfold over years and decades. This makes them easy to ignore in the short term, but no less real or important. The ocean has momentum. Once changes begin, they continue for a long time. Adaptation in marine ecosystems takes time. Species evolve slowly. Coral reefs take decades to recover from bleaching. Fish populations require years to rebuild. Pushing ecosystems too quickly risks collapse. The ocean can absorb some stress, but there are limits. The ocean's response to change is slow and delayed. Heat absorbed today will affect ocean circulation for centuries. Carbon dioxide absorbed today will alter ocean chemistry for generations. Decisions made now have consequences that extend far beyond any human lifetime. Recovery is possible if conditions stabilize. Marine ecosystems are resilient. Given time and reduced stress, coral reefs can recover. Fish populations can rebuild. But recovery requires that we stop making things worse. It requires stability, and stability requires action. Chapter 9. The Endless Sea. The ocean existed before humans, before mammals, before dinosaurs, before complex life of any kind. It has been here since Earth's surface cooled enough for liquid water to persist. For billions of years, the ocean has defined this planet. The ocean will continue long after human civilizations fade away. Species will come and go. Continents will drift into new configurations. The climate will shift through cycles of warmth and ice. And through it all, the ocean will remain. It is the most permanent feature of Earth's surface. Most of the ocean remains unexplored by human eyes. We've seen fragments, sampled tiny portions, mapped small areas in detail, but the vast majority of the ocean floor has never been directly observed by humans. We know it exists. We can infer some of its characteristics, but we haven't seen it. Mystery defines the ocean in fundamental ways. We don't know what lives in most of it. We don't know all of the processes that govern its behavior. We can measure and model, but much remains beyond our understanding. The ocean is too big, too deep, too complex to ever fully comprehend. In a way, the ocean is Earth's memory. Sediment accumulates on the seafloor, recording history. Chemical signatures preserve information about ancient climates. Fossils document the evolution and extinction of species. The ocean remembers what the land has long since eroded away. Return to the surface. We've descended through 100 facts about the ocean, each one a glimpse into the vast blue world that covers most of our planet. We've travelled from the bright surface where waves dance with light, down through the twilight zone where bioluminescent creatures glow in the dimness, past the midnight zone where pressure and darkness reign, all the way to the deepest trenches where no light has ever reached. The ocean is many things. It is oxygen and climate. It is food and transportation. It is beauty and terror. It is life in forms we're still discovering. It is history written in sediment and chemistry. It is the future unfolding in slow currents. It is, above all, essential. Not just important, essential. Without the ocean, Earth would be a dead world, a barren rock spinning silently through space. But you don't need to think about any of this right now. The facts have been presented. The story has been told. Now you can simply rest. The ocean continues, its ancient rhythms whether we watch it or not. Currents flow, tides rise and fall. Life persists in the depths, all of it happening without any need for human attention. Imagine you're floating gently on the surface now, supported by the water, rocking with small swells, the sun warm on your skin. Or imagine you're sinking slowly through cool darkness, pressure equalizing, everything becoming calm and still. However you imagine it, let the ocean hold you. Let it carry you into sleep. The waves fade, the light dims, the sounds of the surface world grow distant. Only the deep remains, quiet and dark and eternal, exactly as it has been for billions of years, exactly as it will be for billions more. Rest now. The ocean continues without you, and that's perfectly fine. Before we begin tonight's journey, if you're enjoying this content, using hype points on this video helps the channel more than you possibly know. It truly makes a difference in reaching more listeners like yourself. If you're listening on Spotify, leaving a review helps us out so much. And if you'd like, comment what time it is for you and where in the world you're listening from. We absolutely love seeing where everyone is tuning in from across the globe. Finally, if you enjoy this content, subscribing keeps you connected to more stories like this one. Now let's begin. The desert wind moves differently at night. Across the Giza Plateau, where sand meets stone and silence becomes almost tangible, 3 monuments rise against the darkness. They've stood here for longer than most civilizations have existed. They've watched empires emerge and collapse. They've outlasted languages, religions, entire ways of understanding the world. Tonight we're going to walk slowly through the story of the Great Pyramid of Giza. Not the rush tour guide version, not the sensational documentary promising impossible secrets. Just a calm, methodical exploration of what we actually know about the last surviving wonder of the ancient world. Picture yourself standing on the plateau as the sun sets, the heat of the day finally releasing its grip on the sand. The Great Pyramid looms before you, massive beyond easy comprehension, its surface rough and weathered by millennia. This is where we begin our journey through time, through human ambition, through the intersection of faith and engineering that created something genuinely eternal. The temperature drops as darkness approaches. In the desert, the transition from day to night happens quickly, dramatically. One moment the stones are radiating accumulated heat, the next they're cool to the touch. The sky transforms from pale blue to deep indigo, and stars begin to emerge, the same stars that guided the builders who created this monument. We're going to explore every dimension of this structure. Each detail reveals something about the people who built this, the civilization that demanded it, and the mystery that still surrounds it. We'll walk through its history, its construction, its purpose, and its legacy. We'll descend into its hidden chambers and climb through its narrow passages. We'll examine what we know and acknowledge what remains unknown. Let's start at the beginning. in a world so different from ours that it requires imagination just to glimpse it. A world where the Nile flooded predictably each year, where the pharaoh was literally divine, where death wasn't an ending but a transformation into something greater. Chapter 1. The world before the pyramid context itself is where we must begin. The Great Pyramid was built during Egypt's 4th dynasty, a period known as the Old Kingdom. When Egyptian civilization had already been thriving for centuries, this wasn't the dawn of their culture. This was their golden age, their moment of supreme confidence and capability. The Nile Valley during this period was unlike anywhere else on Earth. Annual floods deposited rich silt across the farmland, creating abundance that freed people to pursue specialization. Farmers, yes, but also scribes, priests, craftsmen, administrators, engineers. A complex society with sophisticated bureaucracy, advanced mathematics, and deep religious traditions. The pyramids at Giza were not the first pyramids Egypt had built. By the time Khufu commissioned his great monument, Egyptian engineers had been refining pyramid construction for generations. They had learned from earlier attempts, both successful and failed. The bent pyramid at Dashur shows where angles were adjusted mid-construction. The pyramid at Meidum reveals what happens when outer casing stones aren't properly supported. Each previous structure taught lessons that informed what would be built at Giza. The name we need to remember is Khufu. In Greek histories he's called Cheops, but to his people he was Khufu, the second pharaoh of the 4th dynasty. He ruled sometime around 2600 years before the Common Era, though exact dates remain debated by scholars who work with fragmentary records and astronomical calculations. What isn't debated is his ambition, his vision, his determination to create something unprecedented. Khufu inherited a stable kingdom from his father Sneferu, who had himself built multiple pyramids. The dynasty was at its peak, with resources flowing into the royal treasury, a well-organized administrative system, and the accumulated knowledge of previous generations of builders. Khufu had the means, the expertise, and the divine mandate to attempt something extraordinary. But to understand why the pyramid exists, you must understand how ancient Egyptians viewed their kings. This wasn't a matter of politics or governance as we understand those concepts. Pharaohs weren't simply political leaders who happened to enjoy luxurious lifestyles and commanded armies. They were living gods, divine intermediaries between the mortal realm and the eternal one. When a pharaoh spoke, it was the voice of divinity made manifest in human form. The pharaoh maintained Ma'at, the cosmic order that kept chaos at bay. Without the pharaoh, the Nile might not flood, the sun might not rise, the stars might cease their orderly procession across the sky. This wasn't metaphor to the ancient Egyptians. This was understood as literal truth, as fundamental to the functioning of reality as gravity is to our understanding of the universe. When a pharaoh died, he didn't simply cease to exist, didn't merely become a memory or a corpse. He transformed, became one with the gods, particularly with Ra, the sun god who travelled across the sky each day in his solar bark, bringing light and life to the world. The pharaoh's death was his apotheosis, his assumption into the divine realm where he would continue to serve as a bridge between worlds. This belief explains something that otherwise seems inexplicable. If a pharaoh was divine, his tomb wasn't just a burial place, wasn't simply a container for a body. It was a transformation chamber, a cosmic launch pad, a permanent dwelling for a god. This explains why Egyptian royalty poured resources into tombs that dwarfed their palaces. The palace was temporary, a place for the brief mortal phase of a divine existence. The tomb was forever, or at least as close to forever as human effort could achieve. Look beyond just Khufu's pyramid for a moment. The entire Giza plateau became a sacred landscape over the course of several generations. Eventually it would hold 3 major pyramids, multiple smaller pyramids for queens, temples both mortuary and valley, causeways connecting these elements, and an entire infrastructure dedicated to the afterlife. This was a city for the dead, but also a factory for eternity, a place where the living laboured to ensure the divine order continued beyond death. Mortuary temples at the pyramid's bases served as interfaces between the living and the dead. Priests performed daily rituals, offerings of food and incense, recitations of sacred texts. These weren't symbolic gestures. The Egyptians believed the pharaoh's spirit needed these offerings, that the rituals sustained the transformed god-king in his eternal existence. The pyramid shape itself wasn't arbitrary. It wasn't chosen simply because it was stable or impressive. The form represented the primordial mound that emerged from the waters of chaos at creation, according to Egyptian mythology. In the beginning, there was only none, the primordial ocean, formless and dark. From these waters rose the first land, the first solid thing in existence, and from this mound the creator god Atum brought forth all of creation. Every pyramid echoed this cosmic moment of creation. But pyramids also represented something else, something visible in the sky. They were stone representations of the sun's rays breaking through clouds, creating a stairway between earth and heaven. Stand in the desert when storm clouds gather and you'll see them, those dramatic rays of light piercing through, creating visible paths from sky to ground. The pyramid made these rays permanent, made them solid, made them a reliable path for the pharaoh's soul to ascend. Every angle had meaning. Every orientation served purpose. Nothing about the pyramid's design was random or merely aesthetic. The slope of the sides, the alignment of the corners, the positioning on the plateau, all of these emerged from careful planning that integrated mathematical precision with spiritual significance. The pyramid required years of preparation before a single stone was quarried. Site selection came first. Why this particular spot on the plateau? Visibility certainly, bedrock quality absolutely, but also astronomical considerations, ritual appropriateness, symbolic meaning. The ancient Egyptians approached this project with the same methodical precision that modern engineers would recognize, just with different tools and different motivations. Astronomical observations determined orientation. Priests and astronomers spent nights watching the stars, marking their positions, calculating alignments. Landscape surveys mapped the terrain and calculated volumes. Scribes recorded measurements, tracked resources, projected timelines. Resource calculations determined how much stone would be needed, how many workers, how much food to feed them, how many tools would wear out and need replacement. Labour organisation required creating entirely new administrative structures. Overseer positions needed to be created and filled. Supply chains had to be established. Living quarters for workers had to be built. Bakeries and breweries had to be constructed to feed the workforce. The pyramids shaped Egypt before construction even began. While we can't pinpoint the exact year construction began, we know it was during Khufu's reign, which lasted approximately 23 years according to ancient king lists. Some estimates suggest the pyramid took 20 to 30 years to complete, which means planning likely began before Khufu even took the throne, during his father's reign, when succession was being prepared and the young prince was learning what would be expected of him. This wasn't just about creating something big, it wasn't about vanity or showing off. It was about creating something perfect, something that would speak to eternity about Egyptian capability, about divine order, about the triumph of Ma'at over chaos. Ma'at was the Egyptian concept of cosmic order and balance, truth and justice, the fundamental rightness of things. The pyramid embodied Ma'at in stone, imposed order onto the landscape, created permanence in a world of change. By the time the first stone was laid, this project had already changed Egypt. It had required reorganization of labour patterns, development of new techniques, creation of infrastructure for transport and logistics. The pyramid shaped the civilization even before it shaped the skyline, demanded innovations that would outlast the construction itself. Chapter 2: A Mountain Built by Humans. When you first see it in person, the scale hits you physically. The Great Pyramid originally stood 481 feet tall. To put that gently in perspective, it remained the tallest human-made structure on Earth for over 3,800 years. Think about that. 38 centuries of human progress, and nothing surpassed it until medieval European cathedrals finally exceeded its height. Try to imagine that span of time. The pyramid was already ancient when the Parthenon was built in Athens. It was already a tourist attraction when Rome was founding its empire. It had stood for over 2,000 years before the first words of the New Testament were written. And through all that time, through the rise and fall of countless civilizations, it remained the tallest thing humans had ever built. Today, the pyramid stands at 455 feet. The difference represents the loss of the pyramidion, the capstone that once crowned the structure, along with settling and erosion over millennia. Even diminished, it dominates the landscape. Modern Cairo has grown around it, buildings creeping closer to the plateau's edge, but the pyramid still commands attention. You can see it from miles away, rising above the urban sprawl. To truly grasp the scale, you need to walk around it. Each side of the base measures approximately 756 feet. The pyramid covers just over 13 acres of desert. To visualize this, imagine walking the perimeter. At a casual pace, it would take you nearly 15 minutes to circle the structure once. 15 minutes of walking past uninterrupted stone and you're back where you started. Stand at one corner and try to see the opposite corner. You can't. The distance is too great, the perspective too vast. The pyramid doesn't just occupy space, it defines it, creates its own gravitational center on the landscape. Those four base sides aren't just roughly equal, they're equal to within inches across lengths of more than 700 feet. The base is almost perfectly level, with variations measured in fractions of an inch. This level of accuracy, achieved without modern instruments, without laser levels or GPS, without even the magnetic compass, remains genuinely remarkable. The surveyors who laid out the pyramid's foundation worked with water levels, measuring rods, and astronomical observations. They created a platform so level that modern instruments struggle to detect variations. On a structure covering 13 acres, this precision borders on the inexplicable. The pyramid contains approximately 2.3 million stone blocks, with a total mass estimated at around 5.9 million tons. To compare, that's roughly the weight of 16 Empire State Buildings. It's a mountain of stone, assembled block by block, each piece cut, transported, and positioned with care. Think about that number, 2.3 million blocks. If you spent 1 second looking at each block, it would take you over 26 days of continuous observation to see them all. And the ancient Egyptians didn't just look at them. They quarried them, shaped them, moved them, and placed them. The average block weighs about 2.5 tons, roughly the weight of a large SUV, but this average conceals variation. Some blocks weigh less than a ton, others weigh significantly more. The pyramid isn't uniform. Its interior contains chambers, passages, and structural features that require different stone sizes. The largest granite blocks, used in the king's chamber and the relieving chambers above it, weigh between 25 and 80 tons each. These massive pieces of stone weren't placed at ground level where you could simply roll or slide them into position. They were lifted and positioned high within the structure's interior, fitted with extraordinary precision. Imagine moving an 80-ton granite block. That's heavier than most modern trucks. Now imagine lifting it 100 feet into the air and positioning it exactly where it needs to be, aligning it perfectly with adjacent blocks. The ancient Egyptians did this repeatedly, without cranes, without hydraulics, without any of the machinery we consider essential for such work. The blocks fit together with joints so tight that you often can't slip a piece of paper between them. This wasn't achieved with mortar filling gaps. The stones themselves were cut and placed with extraordinary precision. Run your hand along a joint between blocks and you'll feel how seamlessly they meet. The precision is tactile, physical, undeniable. From its completion around 2560 BCE until Lincoln Cathedral's central tower was completed in 1311 CE, no structure exceeded the Great Pyramid's height. That's 3,871 years of supremacy. No other building in history has held that record for anywhere close to that length of time. The pyramid defined the limits of human architectural ambition for millennia. The pyramid's internal volume has been calculated at around 2.6 million cubic meters. It's mostly solid stone, with relatively small interior spaces comprising the passages and chambers. The ratio of solid mass to empty space is extraordinary. This isn't a hollow shell, it's a mountain, with narrow corridors carved through it, The pyramid's faces rise at an angle of 51 degrees, 51 minutes. This specific angle wasn't chosen randomly. It relates to both aesthetic proportions and structural stability, creating a profile that has successfully supported the massive weight above for over 4,000 years. Steeper, and the structure might be unstable. Shallower, and it would cover an impossibly large footprint. This angle represents the optimal solution to multiple engineering challenges. Each face of the pyramid covers about 5.5 acres of sloping stone. Originally, with the polished casing stones in place, these faces would have presented smooth, nearly seamless surfaces reflecting sunlight like mirrors. Imagine 5.5 acres of polished white limestone tilted at 51 degrees catching the Egyptian sun. The visual effect would have been overwhelming. The ratio of the pyramid's perimeter to its height approximates 2 times pi, a mathematical constant. Whether this was intentional or coincidental remains debated, but it demonstrates the sophisticated geometric understanding of the builders. Even if they didn't conceptualize pi as we do, they clearly understood the relationships between angles, heights, and perimeters. The pyramid has survived major earthquakes that destroyed other structures in the region. Its form, with a broad base and tapering sides, distributes weight efficiently and provides inherent seismic resistance. When the ground shakes, the pyramid flexes slightly, absorbing and dissipating energy. Its mass provides stability, its shape provides strength. All this mass, all this precision, all this scale required not just vision but practical solutions to impossible-seeming problems. How do you actually build such a thing? How do you organize the work? How do you move the stones? How do you ensure accuracy? These questions lead us to the next chapter, to the practical realities of construction. Chapter 3. How stone became structure. The bulk of the pyramid's limestone came from quarries located right on the Giza plateau itself. The ancient Egyptians didn't transport millions of tons of stone from distant locations. They cut it from the bedrock beneath and around the construction site. You can still see the quarry marks. In the plateau's surface, evidence of where stone was systematically removed. These quarries became part of the construction site's landscape. As workers cut blocks from the ground, they created depressions, channels, ramps. The plateau was reshaped by the act of building, transformed from natural bedrock into a worked landscape of human intention. While local limestone formed the pyramid's core and most of its mass, 2 special types of stone came from elsewhere. White Tura limestone used for the exterior casing was quarried across the Nile River and transported by barge during the annual flood when the river was high. Red Aswan granite used for the king's chamber and internal structural elements came from quarries over 500 miles to the south, a journey that would have taken weeks. The transport of Aswan granite represents a logistical achievement almost as impressive as the pyramid itself. These massive blocks had to be cut from living rock in Upper Egypt, loaded onto barges capable of supporting enormous weight, floated hundreds of miles down the Nile, offloaded at Giza, and then moved from the river to the plateau and up into position within the pyramid's interior. For the local limestone, workers cut blocks free from the bedrock, then moved them using wooden sledges pulled by teams of men. Recent experiments have demonstrated that wetting the sand in front of the sledges reduced friction dramatically, making it possible to move massive stones with human power alone. Water transformed sand from an impediment into a lubricant. This technique appears simple, but represents sophisticated understanding of physics. The workers knew that dry sand would create friction, causing the sledge to dig in and resist movement. Wet sand, however, compacts and smooths, allowing the sledge to glide. Ancient tomb paintings show workers pouring water in front of sledges, depicting this technique in action. The pyramid wasn't built by slaves. Evidence from worker villages, graffiti left by construction crews, and analysis of burial sites indicates the labourers were paid workers, organised into rotating shifts. Many were farmers who worked on the pyramid during flood season, when agricultural work was impossible. They came to Giza, laboured for a period, and then returned to their farms. This wasn't forced labour. This was organised public works, a civic duty that also provided wages and purpose during the agricultural off-season. Calculations based on the number of stones, the time available, and the physical limitations of the work suggest a permanent workforce of around 20,000 to 30,000 people, with possible peak periods employing more. This workforce would have included not just stone movers but also quarrymen, tool makers, rope manufacturers, carpenters, supervisors, scribes, bakers, brewers, and countless other specializations. The pyramid required an entire support economy. Crews had names, left graffiti, proclaiming their achievements, and appear to have engaged in friendly competition. One crew called themselves Friends of Khufu. Another was Drunkards of Menkar. These weren't anonymous slaves toiling in misery. They were organised teams with identity and pride, workers who saw themselves as part of something greater than themselves. The graffiti they left inside the pyramid, marks invisible to anyone not exploring the structure's interior spaces, reveals their pride. They marked which crew had placed which blocks, recorded their names, left evidence of their existence. These marks weren't for public display, they were for themselves, for their gods, for eternity. Archaeological excavations have uncovered worker villages near the pyramid site, complete with bakeries, breweries, workshops, and sleeping quarters. These workers ate well, primarily bread, beer, and meat, suggesting they were valued, not exploited. The bakeries could produce enough bread to feed thousands. The breweries produced beer, which was a staple beverage safer to drink than water. Evidence suggests workers received medical care, with healed fractures showing treatment and recovery periods. The primary stone-cutting tools were copper chisels and saws, along with stone hammers. Copper is soft compared to modern steel, requiring frequent sharpening and replacement, but it was sufficient for cutting limestone when combined with abrasive sand. Workers would saw into limestone using copper blades, pouring sand and water into the cut to create an abrasive slurry that did the actual cutting. For harder stones like granite, different techniques were necessary. Workers used dolerite hammerstones, extraordinarily hard igneous rock, to pound and shape granite blocks. This was slow, painstaking work, but effective. The precision achieved in granite cutting, particularly in the King's Chamber, demonstrates mastery of the material. To achieve the tight joints between blocks, workers likely used a method of repeatedly placing stones, marking high points with red ochre, removing the stone, grinding down the marked areas, and repeating until the fit was perfect. This trial and error approach requires patience, but produces remarkable results. Analysis shows that thin layers of gypsum mortar were used between some stones, but not to hold them together. The mortar served more as a lubricant during positioning, and may have helped with fine adjustments. The weight of the stones above provides the real structural bond. Once in place, the blocks don't need mortar. Gravity and precision do the work. How the Egyptians lifted stones to increasing heights remains partially uncertain, but most theories involve some form of ramping system. Straight ramps extending from ground level to the pyramid's top would require enormous amounts of material and would need to be lengthened as the pyramid rose. Spiral ramps wrapping around the pyramid's exterior could work but would complicate. Corner construction. Internal ramps built into the pyramid structure remain possible but unproven. Evidence exists for all these approaches, suggesting the Egyptians may have used different methods at different stages of construction. Pragmatism likely trumped dogmatic adherence to a single technique. If one approach worked better for a particular challenge, they used it. Despite everything we know, significant questions remain about specific construction techniques. The absence of detailed construction records from the period means we're often working backward from the finished product, deducing methods from results. This isn't failure of archaeology. This is the nature of studying a civilization that didn't document their building techniques because they were common knowledge at the time. The pyramid's construction required not just labour, but logistics, coordination, resource management and planning that would challenge modern project managers. Feeding 30,000 workers daily meant producing thousands of loaves of bread and gallons of beer every day. Maintaining tool supplies required a steady production of copper implements. Coordinating stone delivery from multiple quarries demanded scheduling and communication systems. If the pyramid took 20 years to complete and contains 2.3 million blocks, workers would have needed to place approximately 315 blocks per day, every day, for 2 decades. This seems impossible until you remember this wasn't sequential. Multiple teams worked simultaneously on different sections. Different quarries provided stone concurrently. The project progressed on many fronts at once. All this effort, all this organisation, all this daily labour over decades served not just to create mass, but to create alignment, to achieve something beyond mere construction. The pyramid wasn't just big, it was oriented, aligned, positioned according to principles that connected earth to sky. Chapter 4: Order in the Stars. The Great Pyramid is aligned to true north with an accuracy of about 4 arc minutes, or 1/15th of a single degree. This precision exceeded the capabilities of compasses, which the ancient Egyptians didn't possess. They achieved this alignment through careful observation of the stars, a technique that required patience, mathematical understanding, and sophisticated astronomical knowledge. The most likely method involved observing circumpolar stars, stars that never set below the horizon as they wheel around the celestial pole. By tracking a star's rising and setting points on an artificial horizon and bisecting the angle between them, ancient astronomers could determine true north with extraordinary accuracy. This required building observation platforms, marking positions, performing calculations, and checking results multiple times. Some researchers have proposed that the 3 pyramids of Giza align with the 3 stars of Orion's belt, a constellation, the Egyptians associated with Osiris, god of the afterlife. While this correlation has been debated and remains controversial in academic circles, the Egyptians definitely viewed the sky as a map of the divine realm. Stars weren't just points of light, they were gods, destinations, the architecture of heaven. The 4 faces of the pyramid align precisely with the 4 cardinal directions: north, south, east, and west. This ensured the structure harmonized with the sun's daily journey across the sky, reinforcing the connection between the pharaoh and the sun god Ra. Each face caught the sun at different times, creating a daily cycle of light and shadow that echoed the sun god's journey. 2 narrow shafts extend from the king's chamber, one pointing north, one south. Similar shafts exist in the queen's chamber, though these don't extend all the way through the pyramid's masonry. These weren't ventilation shafts in any practical sense. Air circulation wasn't necessary in a tomb. They appear to have had astronomical or spiritual significance, possibly representing pathways for the pharaoh's soul to ascend to specific stars. The southern shaft from the king's chamber, when the pyramid was built, pointed directly at Al-Nitak, the brightest star in Orion's belt during its culmination at the meridian. Whether this was intentional remains debated, but the precision of the alignment is undeniable. The shaft isn't just vaguely pointing south. It's aimed at a specific celestial target. The northern shaft from the king's chamber, at the time of construction, aligned with Thuban, then the pole star in the constellation Draco. This alignment would change over time due to Earth's axial precession, the slow wobble of our planet's rotation that causes the position of the pole star to shift over thousands of years. This makes the shaft a timestamp, evidence of exactly when the pyramid was built. The Egyptian concept of Ma'at, cosmic order and balance, pervades every aspect of the pyramid's design. The precise alignments weren't just technical achievements, weren't simply the result of engineers showing off their skills. They represented the imposition of divine order onto the physical world, ensuring the structure harmonized with eternal cosmic patterns. The pyramid was meant to function not just as a building, but as a cosmological instrument, a physical embodiment of the relationship between Earth and heaven. While we can measure these alignments precisely today using modern instruments, we can't always know their exact significance to the ancient builders. We're looking at their choices through our modern understanding of astronomy, which may not fully capture their spiritual and cosmological framework. They saw meaning in the stars that goes beyond our cataloguing of positions and magnitudes. We've examined the pyramid from outside, traced its connections to Earth and sky, explored its relationship to cosmic order. Now it's time to enter to explore the hidden chambers carved into millions of tons of stone, to walk passages that have existed in darkness for millennia. Chapter 5. Inside the Pyramid. The original entrance is located on the north face, about 55 feet above ground level. This wasn't the entrance tourists use today. That was created by workers digging for treasure in the 9th century, breaking through the masonry in an attempt to reach whatever riches they imagined lay within. The hole they created bypasses the pyramid's original entrance system, providing direct access to the interior. From the original entrance, a narrow corridor slopes downward at an angle of 26 degrees, cutting first through the pyramid's masonry, then through the bedrock beneath. This passage is only about 3.5 feet tall, forcing anyone traversing it to stoop or crawl. The walls are smooth, the angle constant, the construction precise even in this hidden space where no one was meant to see. The descending passage eventually opens into a rough-cut chamber carved from bedrock, located about 90 feet below the pyramid's base. This chamber appears unfinished, with an irregular floor and a shaft descending even deeper into the bedrock, extending down into darkness. Its purpose remains unclear. Was it abandoned when plans changed? Was it always meant to be unfinished, representing the underworld's chaos in contrast to the finished chambers above? We don't know. About 60 feet from the entrance, a different passage branches upward from the descending corridor, also at an angle of 26 degrees, but climbing into the pyramid's interior rather than descending beneath it. For centuries, this passage was concealed by a fitted stone plug, hiding the pyramid's true interior from anyone who entered through the north face. The passage was invisible, a secret route to chambers above. The ascending passage is narrow and low, barely allowing passage, maintaining the same uncomfortable dimensions as the descending corridor. You can't walk upright, you can't move quickly. Every foot of progress requires effort and attention. But this passage climbs toward the pyramid's heart, rising through solid masonry towards something extraordinary. The ascending passage opens into the Grand Gallery, one of the ancient world's most remarkable architectural achievements. This corbelled passage soars 28 feet high, while maintaining the same upward angle as the ascending passage. The walls step inward as they rise, creating a narrow ceiling despite the impressive height. The effect is cathedral-like, unexpected in a space that spends most of its existence in complete darkness. The Grand Gallery's function remains debated. Some theories suggest it housed sliding granite blocks that would seal the ascending passage after the pharaoh's burial. Others propose it served a ceremonial function during the pyramid's construction and consecration. The space feels too grand, too carefully constructed to serve a purely utilitarian purpose, yet its exact role in the pyramid's design eludes certain explanation. At the top of the Grand Gallery, through a narrow antechamber with granite portcullis blocks that could have sealed the chamber beyond, lies the King's Chamber. This room measures about 34 feet long, 17 feet wide and 19 feet tall. Every surface is lined with red Aswan granite, brought from quarries over 500 miles to the south. The stone's polished surface catches light, reflects sound, creates an environment unlike anywhere else in the pyramid. In the King's Chamber sits a rectangular granite box, slightly larger than a human body, with one corner broken. This is assumed to be Khufu's sarcophagus, though no body or burial goods have ever been found within the pyramid. The lid is missing. The interior is empty. Whether it was robbed in antiquity or never used remains unknown. Some argue the pyramid was looted before historical records began. Others suggest it never functioned as a tomb at all, that its purpose was symbolic or ceremonial rather than practical. Unlike the treasure-filled tomb of Tutankhamun discovered by Howard Carter in the Valley of the Kings, the Great Pyramid has yielded no mummy, no grave goods, no definitive proof it ever served as an actual burial site. This absence has fueled centuries of speculation about the pyramid's true purpose, spawning theories ranging from astronomical observatory to power plant to grain storage. The simplest explanation remains that it was robbed thoroughly in antiquity, but the complete absence of evidence makes certainty impossible. Returning to the ascending passage, taking a different route this time, we find a horizontal passage branching off about halfway up. This leads to what's known as the Queen's Chamber, though no evidence suggests it was intended for a queen. The name is a modern convention based on mistaken assumptions about Egyptian burial practices. The Queen's Chamber sits almost exactly on the pyramid's east-west centerline. It measures about 17 feet square and 20 feet tall, with a pointed corbelled ceiling similar in construction to the Grand Gallery, though much smaller in scale. A niche is cut into the eastern wall, its purpose unknown. Was it meant to hold a statue, an offering? Did it serve some function we can't reconstruct from the empty cavity that remains? The floor of the Queen's Chamber remains rough and unlevelled, suggesting the chamber may have been abandoned before completion. Whether this represents a change in plans, an intentional choice to leave it unfinished, or simply work interrupted by Khufu's death and burial, we cannot say with certainty. Above the King's Chamber, explorers in the early 19th century discovered 5 additional chambers stacked vertically. These weren't designed for access. There are no entrances from the normal passage system. They were discovered by breaking through from the Grand Gallery, creating holes in the masonry to see what lay beyond. These chambers serve as stress-relieving structures, distributing the immense weight of the pyramid above so it doesn't crush the King's Chamber below. The relieving chambers are constructed of massive granite beams laid horizontally, creating open spaces between them. The topmost chamber has a pointed limestone roof, designed to deflect weight outward to the pyramid's sides. Together, these chambers have protected the King's Chamber from collapse for over 4,000 years. Without them, the weight would have crushed the chamber below, reducing it to rubble. The King's Chamber has unusual acoustic properties. Sound resonates within the granite walls in specific ways, creating harmonics and echoes that transform simple sounds into something more complex. Whether this was intentional or coincidental remains debated. Some researchers have experimented with chanting and musical instruments in the chamber, noting unusual resonances. Did ancient Egyptians use this space for ritual purposes involving sound? We can only speculate. We've explored the interior, walked the passages, stood in the chambers, but we've only seen the pyramid as it exists today, stripped of its original covering, weathered by millennia. To understand how it once appeared, we must reconstruct what was lost. Chapter 6. The Lost Skin of Light. Originally, the entire structure was covered in polished white Tura limestone casing stones. These weren't rough blocks like those visible today, weren't the weathered stepped surfaces that tourists photograph. They were precisely cut, polished to a near-mirror finish, and fitted together with joints measured in fractions of an inch. The pyramid wasn't rough, it was smooth. The visual effect of the polished casing would have been transformative. When new, the pyramid didn't look like a stepped stone structure, didn't reveal the internal construction. It appeared as a smooth, gleaming surface, its polished faces reflecting sunlight with eye-searing intensity. Early observers described it as appearing to be made of light itself, a beacon visible for miles. Imagine sunrise at Giza. As the sun crested the eastern horizon, the pyramid's eastern face would catch the first rays, transforming into a blazing triangle of reflected light. The effect would have been visible for miles across the Nile Delta, announcing the presence of divine power made manifest in stone. As the sun climbed, different faces would catch the light, creating a daily cycle of illumination that echoed the sun god's journey. In the clear desert air, the polished pyramid would have been visible from extraordinary distances. Travellers approaching Cairo from any direction would have seen the pyramids long before reaching them, their white surfaces standing in stark contrast to the golden desert sand. They would have appeared to float above the horizon, shimmering in the heat haze, otherworldly in their perfection. The casing stones came from Tura, a limestone quarry across the Nile from Giza. Tura limestone is finer grained and whiter than the local limestone, making it ideal for a polished finish. Transporting these precisely cut stones across the river and up to the pyramid site represented a significant logistical achievement. Each stone had to be protected during transport to prevent damage to its polished surface. Over centuries, and particularly after a major earthquake in the 14th century loosened many casing stones, the polished covering was systematically stripped away. Medieval builders used the fine limestone to construct mosques and buildings in Cairo. The pyramid became a quarry, its outer skin harvested to build other structures. What took decades to construct was dismantled over centuries of opportunistic stone harvesting. A few casing stones remain in place at the pyramid's base, protected by accumulated debris and fallen blocks. These fragments allow us to see the original surface treatment, confirm descriptions from earlier observers, demonstrate the precision of the cutting and polishing. Running your hand along one of these surviving stones, you can feel how smooth it is, how carefully finished, how different from the rough core blocks now exposed. The pyramidion, the capstone that once crowned the pyramid, was likely covered in gold or electrum, a gold-silver alloy. This would have made the pyramid's peak shine even more brilliantly than its white sides, marking the convergence point of the four faces and the symbolic link between earth and heaven. The golden cap would have caught the sun's first and last rays each day, visible as a point of light long before the rest of the pyramid emerged from darkness. The casing stones weren't just cut and polished. Each one was shaped to fit its specific position on the pyramid's face, accounting for the slight curve of each face and ensuring the smooth transition from base to apex. This required mathematical calculation for each stone's angle and precise execution in cutting. Each of the approximately 144,000 casing stones was unique. Stripped of its casing, the pyramid looks ancient, weathered, mysterious in its roughness. But we must remember, for most of its existence, it looked new, intentional, triumphant. What we see today is the skeleton, the core exposed. What the ancients saw was the finished achievement, perfect and gleaming, a monument that announced Egyptian power and divine order to anyone who saw it. The transformation from polished magnificence to rough pyramid took centuries, happening gradually as stone was removed for other projects. By the time Napoleon saw the pyramids in 1798, they already looked much as they do today. Their covering long gone, their original appearance preserved only in written descriptions and the few fragments still clinging to the base. Chapter 7. Misunderstood. For centuries, the pyramid wasn't built by slaves. This misconception, popularized by ancient historians like Herodotus, who visited Egypt 2,000 years after construction, and reinforced by biblical narratives and Hollywood films, contradicts all archaeological evidence. The builders were skilled workers, compensated for their labor, proud of their achievement. The persistence of this myth says more about later cultures' assumptions than about ancient Egyptian reality. The precision and scale of the pyramid have led some to claim it couldn't have been built by ancient humans and must represent alien intervention or lost advanced civilizations. These claims ignore both the archaeological evidence of Egyptian capability and rest on the assumption that ancient non-European peoples couldn't achieve sophisticated engineering. The pyramid is impressive precisely because humans built it, because it represents what organized, sustained human effort can accomplish. When classical Greek and Roman civilizations encountered the pyramids, Egypt's pyramid-building age was already more ancient to them than Rome is to us. They marveled at the structures, but often misunderstood their purpose, ascribing them to vanity and hubris rather than religious devotion. Herodotus recorded stories about Khufu that portrayed him as a tyrant who enslaved his people, narratives that tell us more about Greek assumptions than Egyptian reality. During the Islamic medieval period, some believed the pyramids contained vast treasures or ancient wisdom preserved from before the Great Flood. This led to multiple attempts to break into them, including the creation of the entrance tourists use today, forced through the masonry in search of riches that didn't exist. These treasure hunters did permanent damage, creating passages that bypassed the pyramid's original entrance system. Various claims assert the pyramid encodes pi, the golden ratio phi, the speed of light, the Earth's dimensions, or other constants. While some proportional relationships exist, attributing modern mathematical constants to ancient builders requires selective measurement, and often ignores the evidence of how such proportions actually arose from practical building decisions and aesthetic choices rather than intentional encoding of universal constants. The ratio of the pyramid's perimeter to its height approximates 2 times pi. However, this can arise naturally from using a rolling drum to measure and establish the angle, a technique that would have been available to ancient builders without requiring knowledge of pi as an abstract constant. The relationship is real, but it doesn't necessarily indicate intentional encoding of mathematical knowledge. Some claim the pyramid's proportions reflect the golden ratio, phi, a number found throughout nature and art. While certain measurements create ratios close to phi, these can be explained by the pyramid's angle and the geometric properties that angle creates, rather than intentional encoding. The Egyptians had sophisticated mathematical knowledge, but we must be careful about projecting our mathematical concepts onto their design choices. Serious scientific study of the pyramids began in the 19th century, when scholars like Jean-François Champollion's decipherment of hieroglyphics allowed researchers to actually read ancient Egyptian texts. This transformed understanding from speculation to evidence-based analysis. For the first time, researchers could read what Egyptians wrote about themselves, their beliefs, their practices. The 20th century brought systematic excavation, careful documentation, and scientific analysis. Rather than seeking treasure or mysteries, researchers focused on understanding the pyramids in their cultural and historical context. Excavations of worker villages, analysis of tools and techniques, study of contemporary texts and records, all built a comprehensive picture of how and why the pyramids were built. Despite centuries of study, significant questions remain. This doesn't validate wild theories or suggest hidden knowledge. It simply reflects the reality that ancient Egypt predates detailed written construction records, leaving us to deduce techniques from physical evidence and fragmentary texts. Mystery isn't proof of the impossible, it's just the natural state of studying the distant past. Chapter 8. Modern Discoveries. In recent decades, researchers have begun using non-invasive scanning techniques to study the pyramid's interior without drilling or damaging the structure. These methods include muon radiography, which uses cosmic ray particles to create density maps, infrared thermography, which reveals temperature variations indicating hidden chambers, and three-dimensional laser scanning, which creates precise models of the pyramid's geometry. The Scan Pyramids project, beginning in 2015, used cosmic ray muon detectors to create images of the pyramid's internal density. Muons are particles created when cosmic rays strike Earth's atmosphere. They penetrate stone but are partially absorbed based on density, allowing researchers to map internal voids. The technique is slow, requiring months of data collection, but completely non-invasive. In 2017, the Scan Pyramids team announced the detection of a large void above the Grand Gallery. This space, approximately 100 feet long, was previously unknown. Its purpose and contents remain mysterious, as it's inaccessible without creating new passages through the pyramid, something researchers are unwilling to do. The void exists. We know its approximate size and location. What it contains remains unknown. Small robots have been sent through the narrow shafts extending from the King's Chamber and Queen's Chamber, carrying cameras to document areas humans can't reach. These explorations have revealed previously unknown chambers and features, small spaces carved into the pyramid's interior. Each discovery raises new questions about the pyramid's design and purpose. The robots exploring the shafts from the Queen's Chamber encountered stone doors with copper handles. When carefully drilled and explored, these led to small spaces, then additional doors. What lies beyond remains unknown. Each answer reveals new mysteries, new spaces we didn't know existed. Modern archaeology moves slowly, prioritizing preservation over discovery. Each intervention must be carefully planned to minimize damage. This means some mysteries may remain unsolved for years or decades until technology advances sufficiently. We could find answers faster if we were willing to break through walls and drill into chambers, but the cost would be irreversible damage to an irreplaceable structure. New discoveries in Egypt continue regularly, not just at Giza, but throughout the Nile Valley. Ancient settlements, quarries, worker villages and texts continue to emerge from the sand, each adding pieces to our understanding of the civilization that built the pyramids. Each new tomb discovered, each papyrus translated, each settlement excavated, adds context to the pyramids themselves. The pyramids of Giza, along with the entire Memphis necropolis, were designated a UNESCO World Heritage Site in 1979. This classification provides international protection and recognises the pyramids as heritage belonging to all humanity, not just Egypt. The designation comes with responsibilities for preservation and careful management. Millions of people visit the pyramids annually, creating both economic benefit and conservation challenges. Balancing access with protection requires constant effort. Human presence accelerates deterioration through humidity from breath, erosion from touch, simple physical contact. Managing tourism while preserving the monuments requires ongoing vigilance and careful planning. Desert conditions have preserved the pyramids better than any other environment could, but they're not immune to environmental damage. Wind erosion gradually wears away exposed surfaces. Salt crystallization, when rare moisture penetrates the stone and then evaporates, can crack and crumble the limestone. Occasional rain, though rare, can cause damage. Temperature fluctuations between scorching days and cool nights create expansion and contraction that slowly wears the stone. Chapter 9. The Pyramid Today. The Great Pyramid has stood for over 4,500 years. It predates classical Greece by 2,000 years. It was already ancient when Rome was founded. It stood finished for over 1,000 years before the first books of the Hebrew Bible were written. Try to grasp that span of time. 45 centuries, more than half of recorded human history. The pyramid has survived countless earthquakes, including major tremors that destroyed other structures in the region. Its form provides inherent stability, and the precision of its construction has allowed it to flex and settle without catastrophic failure. When the ground shakes, the pyramid absorbs the energy, moves slightly, then settles back into stability. Its mass is its protection. Despite modern Cairo's expansion, despite the sprawl of buildings that now reach nearly to the plateau's edge, the pyramid still dominates the landscape. From many parts of Cairo, you can look up and see it, exactly where it's always been, unchanged while everything around it transforms. The city grows, changes, rebuilds itself generation after generation, while the pyramid remains. The pyramid represents many things to many people: ancient achievement, human ambition, religious devotion, engineering triumph, historical mystery. It's been called the machine of eternity, the mountain of light, the throne of Pharaoh. But perhaps most fundamentally, it's evidence that humans, working together with purpose and dedication, can create something that transcends their individual lifespans and speaks across millennia. Tonight, the desert wind still moves across the Giza plateau. The stars wheel overhead in patterns that have shifted since the pyramid was new. The pole star no longer where it was when those astronomical shafts were aimed. Sand accumulates and is blown away, accumulates again. The sun rises, blazes across the sky, and sets as it has done more than 1.6 million times since the final block was placed. The pyramid doesn't need us to understand it. It doesn't require our theories or our amazement. It existed for thousands of years before modern archaeology, and it will exist long after we're gone. But we're drawn to it anyway, generation after generation, seeking meaning in its massive permanence, finding questions in its precise angles. As you drift towards sleep tonight, imagine standing at the pyramid's base as darkness settles completely. The rough stone rises above you, each block, representing countless hours of human effort. Somewhere within, the king's chamber sits empty, sealed in darkness, unchanged since the last torch was extinguished millennia ago. The grand gallery angles upward through millions of tons of stone. The shafts point towards stars that have shifted in the sky. The pyramid keeps its secrets, not out of malice or mystery, but simply because it is stone. It cannot speak, it can only stand. And in standing, It reminds us that humans, for all our limitations, for all our brief individual existence, can create something that outlasts empire, outlasts language, outlasts everything but time itself. The desert wind continues its eternal movement across the sand. The pyramid remains, exactly where it has always been, exactly what it has always been, a monument to belief, to effort, to the uniquely human drive to create something eternal. Rest now. The pyramid has stood for 45 centuries. It will still be standing when you wake.